Hey guys, in this video we're going to look at a harder example of calculating empirical formula. And we're going to look at the chemical porphryn, which you will find in hemoglobin in your blood. And the question is available in the description on YouTube, or for my Tamaki students it is available available on the Google site. Now, remember to start off, we have our percentages. So porphryn, you'll see in the question, contains 78.5% carbon. It also has 3.2% hydrogen, and finally 18.3% nitrogen. Now remember, because we're dealing with percentages, our first step is to assume that we have 100 grams of the sample, and that means we can convert our percentages into masses, assuming we have 100 grams. So our mass of carbon is equal to 78.5 grams. Our mass of hydrogen is equal to 3.2 grams, and our mass of nitrogen is equal to 18.3 grams. Cool, now we have our mass. Our next step is to calculate the number of moles of each element. So we'll start with nitrogen. Our number of moles, nitrogen. We'll start with carbon. Our number of moles of carbon is equal to the mass, 78.5 grams, divided by the molar mass, which for carbon is 12.0 grams per mole. And if we pass it through a calculator, you should hopefully figure out that that is 6.54 moles. If I made a mistake, let me know. Next one is the number of moles of hydrogen, and that's going to be equal to the 3.2 grams divided by 1.0 grams per mole. Let's make that a little longer. That one's nice and easy. We get 3.2 moles. And finally, our number of moles of nitrogen is equal to 18.3 grams divided by 14.0 grams per mole, which is the molar mass of nitrogen. And when that comes out of our calculator, we find that we have 1.31 mole. Excellent. So, where are we at? We have our number of moles of each of our three elements. And what we want to do is we want to work out the ratio of moles. Now, remember, the easiest way to do that is, so we flick to another color. Easiest way to do that is we want to divide by the lowest number of moles. In this case, our nitrogen is 1.31, so we're going to divide all our three numbers of moles by 1.31 to get our ratio. Alright, so for nitrogen, that's nice and easy. 1.31 divided by 1.31 is just 1. For our hydrogen, 3.2 divided by 1.31 works out to be 2.44. And 6.54 divided by 1.31 turns out to be 4.99. Now, I said at the start of the video that this one was going to be a little bit harder. And the reason for that is, if we look at our numbers when we're forming our ratio of, carbon to hydrogen to nitrogen, you notice that when we round these, we get 5, because 4.99 is basically 5, and we've got 2.44, which is a bit of a problem, because that really is 2.5. We can't have that as, we can't round that to 2, it would just be far too inaccurate, and our nitrogen stays at 1. So what we actually need to do, and this is why it's a little bit harder, because we have 2.5, we just need to double everything so we get a whole number. So when we double it, we get nice whole numbers, and we can make our empirical formula. So that gives us 10 and 5 and 2. So our empirical formula works out to be C10H5N2. Empirical formula of porphyrin. Nice and easy. Now, the question also tells us that porphyrin has a molar mass, let's go to a nice bright green color. Porphyrin has a molar mass of, so that's capital M, a molar mass of 306 grams per mole of porphyrin. Now, if we want to calculate what the molecular formula of porphyrin is from our empirical formula, we need to work out what the molar mass of our empirical formula is, the empirical formula, which is that. I'm just going to do it in my head because it's pretty easy, but you just want to add up, well, hopefully you should be able to work out molecular formulas, but 10 carbons is going to equal 120 plus 5 hydrogens is going to be 125, plus 2 14s is 28, so that's going to be 153, am I right? Equals 153 grams per mole. Now all we need to do to find the molecular formula is we want to go this one, the molecular formula divided by the empirical formula. So if we go 306 divided by 153, that's going to equal 2. And because it's 2, that just means we have to multiply the empirical formula by 2. So the molecular formula is going to be C20H10N4. And that is our molecular formula. Any questions, guys, please leave me a comment or send me an email. Leave a comment at the bottom of the video or hit me up at hipsterchemistry@gmail.com. Thanks very much.